The bones in this picture are bird bones on the left, mammal bones in the middle, and fish bones on the right. I'm Mike Etnier, and I'm a zooarchaeologist. I work at Western Washington University. I'm going to talk about bones and how bones can be used to understand climate change. Okay, wait, looking at bones, how does that work? We're trying to understand climate change. So scientists have used plant remains for a long time to understand climate change. They've looked at changes in pollen records, they've looked at changes in plant macrofossils, and as climate change happens in a particular area, the plants that grow in that area also change. And geological deposits that have those fossils in them record that change. We're looking at bones from archaeological sites to see if we can see any evidence of climate change in the archaeological record, looking at sites that come from western Alaska, mostly the Alaska Peninsula and the Kodiak Island area. A zooarchaeologist is a scientist who studies bones and shells and other hard remains from archaeological sites. They tend to represent leftover food refuse or discarded food items, and they tend to show up in fairly dense accumulations that are called middens. We don't know why people all over the world threw their trash into piles, but people have done it for a very long time. When scientists talk about weather, they're talking about changes that are happening in the atmosphere right now. It's really a short-term kind of a measurement of what's happening in the atmosphere. Climate is the long-term average of what weather has been happening in a region. Weather patterns tend to be measured on the order of days or months, whereas climate changes are measured on the order of hundreds of years or decades. Scientists have divided the world into large climate regions. If you look at the map here, there's the humid subtropical region, and as climate changes, you might expect that that area would expand, maybe to the north, for instance. So now let's get back to how we're going to be using bones to understand this. If we imagine a particular species that's well suited for its particular climate, like we'll use the example of a California sea lion. California sea lions live on the coast of North America and tend to like fairly warm climate. If climate then warms up in the future, we might expect that the range of habitat where California sea lions are comfortable would expand to the north. Okay, so wait a minute. We've already discussed how weather and climate are different. It's a matter of time scale. If I'm trying to find evidence of climate change by looking at bones that show up in archaeological sites, how do I tell the difference between something that reflects a change in weather, something over very short term, versus something that reflects change in climate, something over the long term? And that's mostly a matter of scale again. If an archaeologist digs a site in, say, Alaska and happens to find one bone from a California sea lion, that probably reflects a single event, a single weather anomaly, something on a very short term. But if we start to find archaeological sites throughout coastal Alaska that have lots of California sea lion bones in them that all date to a certain time period that happens to correspond to a time period that was relatively warm compared to now, then we might think that that reflects climate change. So now we get into the case of how does a zooarchaeologist interpret these remains? If we're only looking at one particular site, then it becomes a little difficult to know how important that particular pattern is to the overall pattern in the region. But the zooarchaeologist will hopefully have access to data from lots of different sites and can start to figure out if it's more of a regional signal that relates to climate change, or perhaps just a single event that relates to a weather event. So you can imagine a particularly warm summer, for instance, a change in the weather, where California sea lions would range a little further north than normal. Over the long term, if that's consistent, then we would start to think of it as climate change, because again, climate change is the long-term trends in weather. So as climate warms, California sea lions may move their geographic distribution further north. Their home range may expand, maybe all the way up into Alaska. Animals like California sea lions could be indicative of those changing patterns. In general, I use this example to show the kinds of changes that we would expect to see in the distribution of any given species through climate change. It could be shifts in eider populations, it could be shift in walrus populations. It doesn't matter which particular species we are examining, we just need to have an understanding of what their habitat preferences are today and see how that would change under different scenarios of climate change.